Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is MUSTAQIM bin ROSMAN RIZAL. My matric card number is B091910381. Okay, so now I will present my project for PSM 1. Okay, my project has been supervised by Encik Aludin bin Muhammad Sarah. Okay, so for my project, I will prepare geopolymer mortar from waste product like fly ash, and then it will be incorporated with phase change material PSM. It will be used as building passive cooling application. Okay, before I continue to objective and methodology of my project, first I will go through about background of my project. Okay, building energy consumption. Energy is a critical physical input for a country development. Many emerging countries are become more energy intensive in terms of high quality energy use. Okay, from the pie chart, it shows that energy consumption by sector in Malaysia. The higher sector that consume energy is the industry sector, that consume almost 43%. This is because industry are using large machine. Then it followed by transportations. Okay, most office and commercial building use air conditioning that consume largest amount of electricity. The bar chart show that the difference between building that use air conditioning device and non-use it. We can see a big different gap between these two. Okay, in order to generate electricity, usually power plant station use coal as its combustion fuel. The coal release CO2 and contribute to global warming. Global warming is originated mainly from the react of the greenhouse gas, particularly CO2. Figure here show how greenhouse effect occur. It is a phenomenon that occurs when solar energy passes through the Earth's atmosphere and heats the surface, but the atmosphere prevents the heat from escaping to space, resulting in a warmer heat blanket involving the Earth's surface. For the refrigerant effect on global warming, the cooling medium that used in air conditioning device also one factor that contribute to global warming. Refrigerant that contain CFC such as R11 have high potential global warming. When CFC released to atmosphere, the sunlight will break the CFC and release chlorine. The chlorine then will react with ozone layer and destroy it, while HFC, HCFC and HFC have lower global warming potential. Okay, then we move to passive and active cooling. Okay, for cooling application, there are two methods that is active and passive cooling. Most of the building in Malaysia use active cooling applications such as fans and air conditioning device, while for passive cooling is a type of cooling that doesn't consume energy because it's more on building design approach that focus on heat gain control and heat dissipation in a building to improve indoor thermal comfort. Okay, thermal energy storage (TES) system can absorb, store or release heat or cool at different conditions such as temperature, place of or power. Sensible and latent heat storage are the example of the thermal energy storage. Sensible heat storage is the most straightforward method. It simply means the temperature of some medium is either increased or decreased, while latent heat storage is associated with a phase transition. The general term for the associated media is phase change material or PSM. Heat can be added or extracted without affecting the material temperature. Storage capacity are often higher as well. Okay, for my project, it will be the latent heat storage system that known as PSM. This diagram shows the mode of action of the PSM. When PSM material absorb heat energy from the environment, they melt. It usually happens around midday when the temperature rises and the phase change to liquid. It will begin to solidify when it releases heat into the environment, which is usually at night when the temperature in the surrounding is low. The phase change will change back to solid. One way for increasing thermal efficiency in building is to incorporate phase change material PSM into the building envelope. Other than that, it also helps to reduce the indoor temperature and energy consumption. The figure shows the way to apply PSM into building material. Okay, for example, the PSM will be filled in the middle of the material constructions. Okay, for the Portland cement, it is the most common material used in the building sector. Despite its widespread use, Portland cement still have disadvantages such as volume change, permeability, limited ductility, and long-term durability. More importantly, the production of the Portland cement consume large amount of heat and electricity energy and produce substantial amount of CO2 gas. This also can lead to global warming. In some applications, geopolymer mortar can be used as variable alternative to Portland cement. This is because geopolymer are made from waste products such as fly ash and palm oil ash. Okay, after that we continue to the fly ash. Fly ash is the tiniest coal ash particles in the form of fine powder. It also a waste product that made from the non-combustible coal particle and a trace of carbon left over from the incomplete combustion. Fly ash also in one of the largest aluminosilicate source of geopolymer mortar. It can be used and converted to the construction material. Since fly ash is an waste from coal combustion, its utilization can help to conserve non-renewable resource. Fly ash can be get from thermal power plant and palm oil waste product. Okay, for the literature review, this is some journal that I have used to guide me in order to collect information and data to achieve the objective of my project. Okay, first is from Muhammad Azizul Ladin, 2014. The main finding is the industry sector accounted for 43% of total energy consumptions. Then Manjusha 2021, PSM integration improve energy efficiency and sustainability by minimizing peak heat flux, temperature variation and CO2 emissions. Then Huang 2019, it said that leakage problem is solved by filling the melted PSM into micron size capsule. Lastly, the Shatnya 2015, the decrease of the compressive strength of the geopolymer mortar due to the added PCM is quite small, and up to 20% of PCM incorporation is sufficiently high for application in building. Okay, then we move to research objective. First is to prepare micro-encapsulated PCM incorporated geopolymer mortar from fly ash as the aluminosilicate source. Second is to determine the optimum parameter for the preparation of the geopolymer mortar with micro-encapsulated PCM, such as mixing ratio of raw material and reaction temperature. Thirdly is to investigate the microstructure and the mechanical properties of the PCM incorporated geopolymer mortar by using several categorization techniques such as SEM, XRD, FTIR, DSC, and universal testing machine. Okay, then this is the flow from my problem statement until objective. First is the energy consumption, go to global warming, passive cooling, thermal energy storage, building application, organic PCM shell, leaking, then micro-encapsulation, geopolymer mortar, process parameters, geopolymer mortar characterization, compressive strength, and then go to the objective. Okay, next is the preparation method for geopolymer mortar incorporated with PCM. This is to achieve the objective number 1. Okay, prepare the alkaline solution by using mixture of an aqueous solution of sodium hydroxide and sodium silicate with ratio 2/1. Mix it together with 1 liter of distilled water. After that, mix the alkaline solution together with 400 grams of fly ash into a homogeneous paste. Then the paste introduced into 380 grams of dry sand and mix for 2 until 3 minutes. During that time, plus extra water and mix into the mixture. Lastly, add 6.7 grams of MPCM into the mixture and continue to mixing for 2 until 3 minutes. Okay, then this is the properties of alkali activators. The molecular formula for the sodium hydroxide is NaOH. For the sodium silicate is Na2SiO3. The color for these two property is white, and the pH level also same, 30 until 14. Okay, then is the micronal PCM. For this project, I will use micronal PCM because the melting point is 23 degrees Celsius and the application is to stabilization of the indoor temperature in the comfort zone, passive and active applications. Okay, for the mix design, I have prepared 6 specimens with different material compositions. Okay, this is for the objective number 2. With this, we can determine the best parameter for geopolymer mixing ratio. Okay, after the mixing process, we go to the casting process. After mixing the geopolymer mixture, it's then cast into the mold. Disposable styrofoam mold were used for casting geopolymer mortar concrete. Then for the curing process, In order to achieve increased strength, the ideal temperature and length of curing are critical in the geopolymerization procedure. Usually, fly ash-based geopolymer mortar were prepared by varying the curing temperature of 18, 100 and 120 degrees Celsius for the duration of 4, 6 and 20 hours. Okay, for objective number 3, there is categorization methods. The method that I use is, first is the compression testing machines. It is to evaluate the resistance of material and product to compression force. Okay, then the XRD is to examine the crystalline structure. Then SEM is to observe microstructure. FTIR is to analyze chemical structure. Lastly, the DSC is to determine the phase change temperature and enthalpies. Okay, for the expected outcome, the preparation of the geopolymer mortar from fly ash that incorporated with PCM or microneedle PCM can be achieved. This also will help to improve mechanical properties and microstructure for building cooling applications. Okay, this is the diagram for my projects. Okay, for the preliminary result, I have used this journal as guide for the data collection method. The title of this journal is Experimental Study of Geopolymer Mortar which incorporated PCM by Shania 2015. Okay, this is the journal front page. The main finding of this journal is to evaluate the effect of incorporated PCM on the physical, mechanical and thermal properties of geopolymer mortar. The unit weight of the geopolymer mortar decreases after PCM is added. The addition of PCM can lead to decrease of the compressive strength. Specific heat capacity increase after PCM is added. The thermal test with cubicle further prove that the geopolymer mortar which incorporated PCM can be used as building wall to effectively increase the thermal inertia of building and reduce the energy demand of cooling and heating. Okay, that's all for me. Thank you.